Hello and welcome back. In the last video, we had a look at setting up a LangChain application in our Node environment. And we also had a look at the fundamentals of using LangChain. If you haven't watched that video yet, I highly recommend watching that video first and then coming back to this video. In this video, we'll move away from standard LLMs and we'll have a look at chat models. Chat models are very similar to standard LLMs and they do use an LLM under the hood. But the big difference is that for LLMs, we pass in a prompt and we get a response back, and that's kind of the end of the conversation. With chat models, we no longer deal with simple text in and text out scenarios, but instead we deal with full-blown conversations, like a chat history. So let's go ahead and create our first chat application. In the root of this project, I'll create a new file and I'll call it chatdemo.js. Let's go ahead and create our model. So at the top of the code, we'll import chat OpenAI from LangChain /chatmodels/OpenAI. And hopefully you can see a small change in the import here. In the previous videos, we imported from the LLM package OpenAI, and the class that we imported was just OpenAI. If I switch back to the demo file for a second, this is what I'm referring to. So in this example, we are accessing the OpenAI LLM directly, but in this file, we are now importing the chat OpenAI wrapper instead. So after importing this, we can instantiate our new model by typing const model equals, and we'll create a new instance of the chat OpenAI class. This class takes in an object as input, and we can also specify the temperature, which I'll set to 0. So far, this looks very similar to the standard LLM, but there is one major difference when calling this model. So let's try and call this model by typing model.call. And this is where the big difference comes in. This chat model takes an array as input, and it's in this array that we will be passing the conversation to the model. And this conversation follows a very specific schema that we have to adhere to. So it will not be possible to just pass in a string like this and expect it to work. But instead, we need to make use of the schemas provided by LangChain. So let's remove this text and let's import those schemas from LangChain. So at the top of the code, we can import human chat message from LangChain /schema. So we can now use this human chat message class to pass in our message to the model. So in this array, I'll pass in a new instance of the human chat message class. And this class takes in our message as input. And let's say that for this example, we want to create a chatbot that can translate text to a different language. So let's ask the model to translate this sentence from English to Afrikaans, which is my native language. And the text that we want to translate is, I love programming. So whenever we want to pass a message that's generated by the user, we will make use of this human chat message schema. This call method returns a promise, which we need to await, and let's assign the result to a variable called res. Let's also console log this result. This model also expects the OpenAI API key to be available, so let's import our environment variables like so. We can now go ahead and save this file. Right, so let's go ahead and test this out. So in the terminal, we can run node and then the file name, which is chat-demo. And let's press enter. And after a second, I get this response back with the text Ek is lief vir programmering, which is Afrikaans for I love programming. And the name is undefined, which is fine. And just a little side note. And this is something I didn't mention in the previous video. When instantiating our model, we saw that we are able to pass several properties to the interface, like the temperature, streaming, etc. There is one more property that you should be aware of, and that is a property called model name. If we pull up the OpenAI documentation for a second, and if we go to models, we can see all the available models in this list. By default, LangChain is using GPT-4 as the model. But if you wanted to use something like GPT 3.5, which is actually a very cheap model compared to GPT-4, we can simply copy the name of the model, and then in our code, we can just pass in the model name. And if we test this out, it should still work. So let's run the script, and there you go. Our model is now using GPT 3.5 Turbo. So I just wanted to mention that you can change your model if you wanted to. So at the moment, we are simply passing in our human chat message, but there are other chat schemas available that you should be aware of, So if we flip back to the OpenAI website for a second, this will visually show you what I'm referring to. At the moment, we passed in a message here for the user. And that message was something like, translate this sentence from English to Afrikaans, or whatever your prompt was. After running this, we got this response back from the AI with a role of assistant. So with this example, we can see the different roles in action. So we've got our user role, which is the user chat message. We've also got this message coming back from the model with the role of assistant. And this is also known as the AI chat message. Then on the left-hand side, we can see the system prompt as well. And this can be used to prime the AI to behave in a certain way or to respond in a certain way. And an example of a system message in this scenario would be something like this, where we tell the AI that you are a helpful assistant that translates English to Afrikaans. So this represents the 3 different chat schemas that is available in LangChain. We've got the human chat message, the AI chat message, and then a system chat message. If we flip back to our code for a second, we can see this in action. So let's say that along with this human chat message, we also want to pass in that system chat message. We can do that by also importing system chat message from the schema package. We ideally want to send that system chat message before our human chat message. So just above the human chat message, I will pass in a new instance of the system chat message, and I will provide it with that priming instruction that says, you are a helpful assistant that translates English to Afrikaans. And I'll just add a comma at the end of this. So now we are passing in our system message as well as our user prompt. And after running this in the terminal, we are still getting our response back. We can also get our model to generate multiple completions. So at the moment, this call is giving us 1 generation. So what if we wanted to generate multiple completions within a single call? As an example, we want to translate this text to Afrikaans as well as French. So for multiple completions, we can actually call the generate function on our model. Generate will provide multiple completions. And with generate, we actually provide an array of arrays. Let's actually remove this array. So we are only left with this generate function call. We will then pass in an array, and I'll just paste in back our original prompt. And what we can do now is provide another array as a value. So I'll just copy all of this and paste it in here. For the second item, I'm going to change the system chat message slightly to say, you are a helpful assistant that translates English to French this time. And then in our human chat message, I'll change Afrikaans to French. I'll go ahead and save this. And then this is basically what this call looks like now. We are now calling the generate function and passing in these 2 arrays as values. Let's run this in the terminal. And in the terminal, we got this response back. And we can see that we are getting this object called generations, which seems to contain 2 objects. So back in the code, I'm just going to change our console log to write out response.generations. Let's execute this again. And now we can see the 2 values that were returned. So we are getting an array. And the first translation is our Afrikaans translation, followed by the French translation. Let's talk about prompt templates with chat models. We can also use prompt templates with our chat models so that we can replace these texts, like the system chat messages, with prompt templates, and then replace the input and output languages with variables. And this way, we've got a very dynamic system. Let's have a look at how we can implement prompt templates with our chat models. So in order to demonstrate prompt templates, I'm actually going to just copy out this code for now, as well as the call to this generate function. And I'll remove this console log as well. Instead of calling these schemas directly, I'm going to remove this import. And what we'll do instead is at the top of the code, we'll import a system message prompt template from LangChain/prompts. And we actually need 2 more imports. We need the human message prompt template. So basically, we will remove the text that we pass into the system chat message and the human chat message with these prompt templates. And in order to tie these 2 messages together into a single prompt, we will also import the chat prompt template. We can define our new prompt template in the code by typing const translation prompt. We'll set that equal to the chat prompt template, and on this class there's a method called FromPromptMessages. And what we're going to do is we're going to pass in the system message as well as the human message. So these two messages that we use down here, we will pass that into this class along with the variables, and that will generate a prompt string that we can pass into the final model or chain. This function takes in an array as input, and this will be the array of messages. So the first message that we want to pass to it is our system message. So we'll pass system message prompt template. On this class, there's a method called FromTemplate, and within this function, we can pass in this string. So I'll just copy it from this example, and let's paste that into this function. And now we can leverage the power of prompt templates. We can now replace this from language and to language with variables. Let's replace English with input language, and we'll replace this language with output language. Right, so this will now allow us to pass in variables when calling our prompt. After the system message, we also want to pass in our human message. So now we can call our human message prompt template class. On this class, there's a method called FromTemplate, and this is going to be the phrase that we want translated, like I love programming. But instead of passing the value like that, we will rather pass in a variable, and I'll call this text. So this translation prompt object will now be able to generate a prompt for our model using the prompt templates that we passed into it. We can have a look at the prompt that this object will generate by calling our translation prompt object. On this object, there's a function called formatPromptValue, and this function takes in an object, and the properties of this object are the variables that we specified in our prompt string. So let's pass in the input language as English. We'll pass in the output language as Afrikaans. And then for the text, we'll pass in I love programming. This function returns a promise, so we can just await that result. And let's assign the result to a variable called formatedPrompt. Let's console log formatedPrompt to see the result. So let's run this in the terminal. And in the terminal, this will look very familiar to you. We now have an array of messages, and in this array, we've got the system chat message with the text, "You are a helpful assistant," that translates English to Afrikaans, and we have our human chat message with the text, "I love programming." So it's taken our prompt templates and converted it into this format that we used earlier. Let's remove this console log. Let's add back in our model. I'm going to go ahead and delete all of this code. And let's now pass in this formatted prompt to our model instead. So we can call our model. On the model, we will now call the generate prompt function because we're using a prompt template. This takes in an array as input, and within this array, we'll simply pass in our formatted prompt. Let's await this response, and let's assign it to a variable called response. Let's go ahead and console log this. So I'll type console log .res, and this will give us an object called generations. Let's go ahead and run this in the terminal, and after a second I get this response back. So at the moment we are creating our formatted prompt and then sending that to the model directly. But in LangChain we want to do things slightly different. Instead we want to use a chain, and it's the chain's responsibility for merging our prompt with our model. So we can also add chains to chat models by importing something from the LangChain package. At the top of the code, we will import the LLM chain from LangChain/chains. I'm going to remove this call on the model as well as this console log. Then what we'll do is we'll define a new chain, which is equal to new LLM chain. This takes in an object with a property for prompt, and for the prompt we will pass in our formatted prompt. It also takes in the LLM, which will set equal to our model. And now, instead of calling the model directly, we can call our chain. On the chain, there's a function called call, and we can now pass in the variable values into this object. So we need to pass it an input language like English. We'll give it the output language as well, which was Afrikaans, and we need to specify the text, which is I love programming. This call function returns a promise, which we need to await, and let's assign this to a variable called response. We should now be able to console log this response. So I'll call console log response, and let's run this in the terminal. And apologies, we do get an error message here, and that is because we no longer need this. So sorry for that. We are now passing the values directly to the chain. So it's this thing here, this translation prompt. This is what we need to pass to our LLM chain. So let's save this value and try again. After running it in the terminal, we can see this response coming back. Great, we are now using chains to combine our model with our prompt templates. Next, let's talk about tools and agents. In the previous video, we discussed what tools and agents are. And for chat models, it's exactly the same. So let me show you how we can introduce agents and tools to our chat model. Let's go ahead and clean up this code. For this example, we won't be using the chain. So I'm just going to remove that. We do need our model, and we're not going to use this translation prompt either, so I'll delete that as well. I'm also going to clean up these imports so that we have a fresh start. Right, so let's have a look at tools and agents. So in this example, we want to ask our chatbot how many people live in the US. We know by now that GPT does not have up-to-date information. So because GPT does not have direct access to the internet, we will use an agent to determine that GPT needs assistance, and it will assign a relevant tool to the model for fetching information from the internet. So the first thing we need to do is to specify the list of tools that we can make available to our model. So I'll define a new variable called tools, which is equal to an array of tools. So, as with the previous video, we will use the SERP API to allow our model to Google for results. So we need to import SERP API from LangChain/tools. Then in the list of tools, we will pass in a new instance of SERP API, and SERP API takes a few values as input. The first is the API key, which we can find in our environment variables by going to process.env.serp API key. The second value is an object with the location details. If you want, you can specify your physical location. I'll just leave that blank. For HL, I'll set EN, and for GL, I'll set US. And this is the only tool that we want to make available to our model. And then we need to create an agent. We can do that by creating a variable called agent. And for agent, we need to import something from LangChain. So what I'll do is I'll say import chat agent from LangChain/agents, and then we can set agent equals to chat agent, and on chat agent we've got a function called from LLM and tools. So what we're saying here is we want to create a new agent from one of our LLMs and the array of tools. So in fact, we actually don't need the model here. So for this function, we need to pass in the LLM, which will be a new instance of our chat OpenAI model. So alternatively, what we could have done here is instead of calling it that way, we could have moved this model up to above the agent, and we could have passed in the model as input. Or you can define it inline. Either way is completely fine. Let's actually leave it like this. The second parameter is the list of tools, which we defined as tools. So now we have an agent that will use our OpenAI model as well as the list of tools to perform the actions. So the agent can't do much by itself, and in order to use the agent, we need to use an agent executor. And the agent executor will effectively call this agent in a loop until the result is found. So let's also import agent executor from the agents package. So below agent, we can now create a new variable for our executor. We will set that equal to our agent executor, and we'll create our executor from our agent and the available tools. So on agent executor, we will call the function from agent and tools. And this takes in an object, and for this object, we need to pass in the agent, which we called agent. The second parameter is the list of tools, which we also called tools. So I know this can seem quite daunting, but basically what we're doing is we're creating a new agent, and agents are quite intelligent in the sense that they will call your LLM model. The LLM will give a response back indicating that it's unable to fetch that information based on its training data. And the agent will then use tools to enrich the prompt that is passed back to the model. And the agent can only use the tools that is assigned to it. An executor is responsible for calling the agents until they find a response. And the executor can also have a list of tools assigned to it. I hope that makes sense. Now that we have our agent and our executor, we can now call the executor to start this process. We can do that by calling executor.run, and we can now pass our prompt to the executor. So let's say, how many people live in the US in 2023? The run function returns a promise, which we need to await, and let's assign the response to a variable called response. And let's console log this response. And let's go ahead and run the script in the terminal. And after a few seconds, we got this response. The projected US population in Jan 1, 2023 is this. And if we had to ask ChatGPT the same question, it will tell us that it actually doesn't have real-time data, and it was last updated back in 2021. So that means that our agent was able to determine that the model does not have this information. So it went back to the tool set and realized that it's now got access to the SERP API tool, and it then Googled the answer, and that's what it returned back to us. So now we know how to create agents and assign tools to our agents. Next, let's have a look at memory. When creating our chatbot, we do want our bot to remember previous conversations, and we can use memory for that. Again, I'm just going to clean up this code, as we don't need most of this. Right, for this memory section, we will be using prompt templates. So I'm just going to import a few things from LangChain /prompts. And what we want to import for now is the chat prompt template, as well as the system message prompt template and the human message prompt template as well. So for our chatbot, let's create our chat prompt using the prompt templates. So for this, let's create a variable called chat prompt, and we'll set that equal to chat prompt template. And on chat prompt template, we'll call this function from prompt messages. This function takes in an array, and the first thing we want to pass is the system message prompt template. And on this class, we've got this method called from template, and it's in this method that we'll pass in the prompt. And we'll use the system message to tell the model that we expect it to behave like a friendly chatbot. So let's pass in a prompt like, the following is a friendly conversation between a human and an AI. The AI is talkative and provides lots of specific details from its context. So what this is saying is the chatbot will remember previous conversations, and here we are telling it to pull specific details from our chat history in the conversations. And let's keep going. If the AI does not know the answer to a question, it truthfully says it does not know. That is quite a long prompt, but that is prompt engineering for you. So it is convention to always pass the system message first, and that is to prime our model. Then, as per the previous example, we want to pass in the human message, which we can do by calling the human message prompt template dot from template, and in parentheses we can now pass the input from the user, which we'll accept as a parameter by using these square braces. But now we need to be careful, because in a conversation we typically want to first pass in the system message. Then as we're talking to our chatbot, the chat history will be built up dynamically. And the human message that we passed here should be the very last message in the conversation. And we are expecting the AI to respond to this last message. But we somehow need to inject the conversation history in between these two messages. So what LangChain will do is it will automatically keep track of the past conversations, so the chat history, and it will inject that history in between these two items. But in order for LangChain to do this, we need to provide a placeholder for the chat history. So in order to use that placeholder, we need to import message placeholder from the prompts package. And now, in between system message and human message, we can pass in a new instance of the message placeholder class. And in this class, we need to specify a unique value, which we'll call history. And we'll get back to this in a second. Basically, how this works is we will instruct LangChain to make use of memory. And we need to tell LangChain where to find this history by providing a key value. This could be anything, by the way. It's simply a reference to the position in memory where LangChain can find these values. So let's continue with the setup. We will now create a new chain, which is equal to the conversation chain, which we also need to import. So in our imports, I will import something from LangChain chains. And from chains, we will import the conversational chain. So in the past, we used the LLM chain, like so. But the conversational chain is like the LLM chain with one addition. It allows us to use memory so that our conversational bot or our chatbot can store the conversations in memory. So back in our code, the conversational chain takes in an object as input. The first property is memory, and at this point we need to create a new instance of the buffer memory object, which is also something that we need to import. So back in our imports, let's import buffer memory from LangChain /memory. So back in our code, we can set memory equal to a new instance of buffer memory. Buffer memory takes an object as input with the property of return messages, which we'll set equal to true. Then the second property is our memory key, which is the key value that we pass into our messages placeholder. And we call this history. So I'll simply copy this and add it to our memory key. Then we also need to pass in the prompt to our conversation chain. And our prompt is equal to our chat prompt, which we specified over here. Then lastly, we also need to specify our LLM, which we haven't created yet. So just below our chat prompt, I will create our new model. I'll just call it model, which is equal to a new instance of chat OpenAI. And I'll just pass in a blank object to use the defaults. So for LLM, we can pass in our model. And let's save all of this. So instead of using the LLM chain, like in the previous examples, we are now passing in the conversational chain. And as with the standard LLM chain, we passed in the LLM as well as the prompt. But the difference between the two chains is that the conversational chain requires this memory object, and this will store our conversation in memory. So let's try this out. On chain, let's call the function call, and let's pass in our prompt. Call takes in an object, and in this object, we need to specify the variable names that we created in our prompt template. So if I go back to our prompt template, we call this variable input. So in the call function, I'll pass in the input property with the value hello from South Africa. Call returns a promise, which we need to await, and let's assign this to a response. And let's go ahead and console log this response, like so. Let's go ahead and run this in the terminal, and after a second we get this response saying, hello there, it's great to hear from you in sunny South Africa. How may I assist you today? Awesome. Let's pass in another message to our model. I'll just call this response 2, and we'll await chain.call, and this time we'll pass it an input asking it, do you know where I am? And let's log this response as well. And let's run this in the terminal. And this time it's saying, as an AI language model, I don't have the ability to know your exact location. However, I can tell that you are in South Africa based on the fact that you mentioned it in your previous message. Awesome. So our chatbot was able to retain this information in memory during this session. So we looked at memory in the previous video as well as in this video, but please note that this is considered to be short-term memory. After the session ends, the memory will be cleared and the model will lose context of our conversation. As an example, if I had to remove the second call to our chain, and let's change the very first call to something like, do you know where I am? I'll save this change, and at this point we are not telling the AI where we are, we're simply asking it where we are. And if we run this, we can now see that the AI is saying that it does not know our current location, and it can try and use our IP address to find our location. But clearly the memory was cleared and it does not have context of our conversation anymore. We will have a look at long-term memory within the series, and in a nutshell, long-term memory means storing this data in a data source like a database or files, etc. Let's also have a look at streaming. As with the standard LLM, we can stream the response from our chatbot, like so. I'm actually going to delete most of this. We will remove this chain, as well as the buffer memory, and I'll also remove this placeholder, as well as the system prompt and the chat prompt. We'll only make use of the human message prompt in this example. First, I'll create a new model called model. I'll set that to new chat OpenAI. Chat OpenAI takes a few parameters. What we are interested in is to set streaming to true. We also have to specify the callbacks, which is an array. And within this array, I'll create a new object that triggers a function called handle LLM new token, which gives us a token as input. And within this function, we'll call process.standardout.write, and we'll pass the token to this write function. And then we can await model.call. Call takes in an array. We'll pass in a new instance of the human chat message. And now that I think about it, we actually don't want to use the prompt template here, so I'll just remove this. And instead, I'll import the human chat message from LangChain/schema. So then we will pass in new human chat message, and we can simply pass our prompt into this. And I'll use the same example as last time. Write a song about sparkling water. Let's save this. And let's run this in the console. And as you can see, we are now streaming the response from the model. Thank you very much for following along, and I do hope you are enjoying this series. If you like these videos, please consider subscribing to my channel, and please like this video. And please have a look at some of my other AI related videos on my channel. Thank you for the support. I'll see you in the next one. Bye bye.